Hello, my name is Ali Sekman. I'm a professor of computer science at Tennessee State University. In this video, I'm going to talk about multi-threaded programming in Java. In other words, you're going to learn how to write programs that have multiple lines of execution. All right, so let's get started. This is for Cont 3110 Java programming, and our topic today is multi-threaded programming in Java. Let's give some definitions. What's a process? A process is a memory space allocated for a program in execution. And for example, when you run Internet Explorer, Microsoft Word, PowerPoint, Visual Studio Code, they all run in a process. A thread is a line of execution in a process. For example, while we are navigating in a web browser, you can download an image and you can scroll down at the same time. So downloading an image is a line of execution. Scrolling down is another one. Maybe sending something to the printer is another line of execution. So processes typically do not share data. Threads can access the data located in a process, but processes typically communicate with each other from a process called marshalling. Of course, we are not going to get into details of those kind of things. So the one of the important classes in this lecture will be thread. Thread is a class located in java.lang package. So that means you don't have to import that package. Let's take a look. You can stop the video and take a look at this slide. Thread extends object. We know that all classes extends from object, either directly or indirectly, and implements runnable. Since I use implements keyword, that means runnable is an interface, okay? So runnable is an interface. In fact, this is runnable interface, which has only one method called run. Okay, and by default, we know that all methods of an interface are public and static. So run is a public and static method of what? Runnable interface. Let's keep that in mind. So that implements runnable. Since runnable has a method, and since I say that I'm going to implement runnable, I must implement the run method, and that's what I do here. This is the default implementation of run method. Recall, it was void run. But by default, it was public. Therefore, I had to use what? Public keyword here. So this is the default implementation of what? Run method of, this is the default implementation of run method of runnable interface. So it has many data members. One of them is target. Target is type of runnable. Another one is a character array. And if you recall, I said the common convention when you see something with capital letters, all capital letters, that is typically what? Final and static defined somewhere in a class. So min underscore priority, all capital, it's a final static member of what? Thread class. It's basically an integer. So instead of remembering 1, 5, 10, which one was what? We just remember as what? Min priority, norm priority, and max priority. It has 7 constructors, okay, but I'm going to give you only 2 of them. One is default constructor. The other one, the other constructor, takes a runnable object as input. Just keep this one in mind, okay? Runnable object as input. Just to sum up, thread is a class which extends from object, implements runnable, and this is the default implementation of run method of runnable. It has many data members. 2 important ones are target, which is a runnable object, name, which is a character array, and there are some final static constants. Final static members are defined here. In fact, they are constant. And then I have public, I have 2 constructors. One is default constructor, another one is what? One input argument constructor, which takes a runnable object as input. There are 5 more constructors and many methods, but we are only focusing on those at this point. Located in java.lang package, so you don't have to import it. And this is the runnable interface, as I mentioned. Runnable interface has only one method called run. So how do we create threads? We are going to focus on 2 different ways. First one is by implementing runnable interface, and second one, extending thread class. So we're going to see both of them. Let's see the first one. Right now we are in this one. Okay. So this is how we're going to do. First, you're going to create a class that implements Runnable Interface. You can have any class that you will create. You will say implements Runnable Interface. Then you're going to create an instance of thread class in your program, but it had multiple constructors, right? You're going to use this constructor to create an object. And then you're going to make a call to the start method of thread class. Okay, so here's what I mean by this. So look here, I have a class, I call it runTest, that implements Runnable. That was the first thing, right? Create a class that implements Runnable Interface. Since that class implements Runnable Interface, it must, what? Implement run method of Runnable Interface. So what does this run method do? It's a very dummy method. It prints from 0 to 10. There's a for loop there. So that was the first step. Create a class that implements Runnable Interface. What is the second step? Create an instance of thread class in your program by using the constructor that takes an instance of your Runnable class. Here, first I create an instance of my runTest. Since runTest implements Runnable, a subclass object is a superclass object. A grad student is a student. A Honda is a car. Never forget that. A runTest is Runnable. Therefore, when I create a target object, which is type of runTest, actually target is Runnable as well. And then I create an object of thread class. While I'm creating, which constructor do I use? I use the constructor that takes a Runnable object as input. Since target is Runnable, target can go there. Okay, that's the second step. What was the third step? Make a call to the start method. And then I make a call to the start method. Start method of what class? Thread class. Okay, so I repeat. And when you run this, this is going to be the output, and I'll tell you how. First, I created a class that implements Runnable Interface, and I did implement run method. Then I create an object of this class, and then I create an object of thread class by using the constructor that takes a Runnable object, and then I make a call to what? To start method. So what happens here is I create thread, and I make a call to start method. When I make a call to start method, that doesn't mean that the thread will immediately start running. First, Java Virtual Machine is going to be checked. If Java Virtual Machine is available, then the thread will start running. And if it is a runnable thread, as I will explain. So running a thread means making a call to the run method automatically. So I created this thread. This was my input parameter to the constructor. When I say t.start, it will start. When it runs, it's going to make a call to run method of what? Target, right there. Okay, so what is the start method? Let's talk about it. Threads do not start automatically. You need to make a call to the start method, but starting the thread does not mean that it runs immediately. There might be many reasons that it may not be runnable at the time. Start takes the thread into runnable mode. If JVM, Java Virtual Machine, is busy, even if you are in the runnable mode, you're not going to be running immediately. Here is the start method. When you have a new thread, you make a call to start, you go to runnable mode. Runnable mode, and if Java Virtual Machine is available, you go to running mode. Running mode means making a call to the run method. If for some reason, if you're blocked, for example, if the program asks the user to enter a number, that means you're waiting for the input from the user. That means you're blocked. You go back to runnable. Okay, you wait, and when the user enters the number, you go to runnable mode. And then whenever JVM is available, you go back to running mode. And while you're running, you may be done. That means you die, and you may get out of the running mode. So this is a little bit confusing part because remember, JVM, Java Virtual Machine, is installed on top of an operating system. For example, when you install JVM on Windows, you install it on top of Windows operating system. Or when you install JVM on Mac operating system, you install it on Mac OS or Linux OS, Unix OS. So it depends on the operating system that you have. So If you have a single CPU system, threads run one at a time to simulate concurrency. Let's say that you have 5 threads, but you have single CPU. I mean, you cannot run them all together, right? So what you do is you run a little bit one, little bit other one, little bit other one. So it somehow simulates concurrency, okay? Some of CPUs shared between multiple threads, the time of CPU. The execution of multiple threads on a single CPU in some order is called scheduling, okay? So you have a single CPU, you have multiple threads, so there should be some kind of order for those threads to run. Maybe one will run a couple of milliseconds, the other one will run a couple of milliseconds. So you can do some kind of scheduling by time sharing. Or you can say, well, depending on the importance of the thread, maybe one thread is more important than the other one. Then you can say, I want to first completely finish execution of the first most important thread. There may be different scheduling mechanisms, okay? So basically the execution of multiple threads on a single CPU in some order is called scheduling. Java Virtual Machine has a loosely defined scheduling policy. So one program that you write may not execute exactly the same in one machine or in one operating system. It may, unfortunately, I mean, it may result different way in another operating system. So you have to be careful. Don't trust too much about the default scheduling of Java Virtual Machine. This is what it is. Since JVM is typically implemented on top of the host operating system, maybe Mac OS, Windows OS, Linux, the priority of a thread is related to the priority of the kernel thread of the operating system. I'm not going to get into details, but you should know that the operating system is important. And sometimes, the scheduling of the operating system will override the scheduling of Java runtime environment. Okay, the regular Java runtime supports a very simple deterministic. You see, this is deterministic. That means every time you run it, it will be exactly the same. Deterministic scheduling algorithm known as a fixed priority scheduling. Okay. So basically, in this one, the algorithms will schedule threads based on their priority relative to the other threads. Let's say that there is one thread which has higher priority than another one. Higher priority is going to run first. Okay. This is preemptive. Preemptive. What does it mean? Let's say that we have multiple threads in the runnable state. So we have runnable state. We have, like, let's say 5 threads that are all runnable. They are ready to run. But with preemptive, only one thread will run. Okay, only one thread runs until it is no longer runnable, or maybe a higher priority thread becomes available. So you pick the highest priority, you start running it. You're going to keep running it until it is done, or maybe another thread comes into the runnable mode and it has higher priority than the currently running thread. Then the higher priority thread preempts the lower priority thread in the preemptive scheduling. Okay, scheduling of the CPU is fully preemptive. So if a thread with higher priority than the currently executing thread needs to be executed, the higher priority thread is immediately scheduled in this one, preemptive scheduling. There's another scheduling, time slicing. Well, regardless of the priority of threads, maybe each thread is gonna be given equal CPU time. So regardless of the priorities, in this case, priority will not be important, okay? A thread may preempt threads of higher priority. So, hey, you executed for a certain amount of time, now it's my turn, no matter how important you are, okay? Even if a thread does not finish executing, the CPU time may be given to another thread. Well, also, let's say that I give you fixed time. You execute, you are not done yet, well, I'm not gonna stop you. I will give time to the other one. Many operating systems support time slicing, okay? When there are multiple runnable threads of equal priority, okay? Well, if you do preemptive scheduling, the Java runtime will not preempt the currently running thread for another thread of the same priority, okay? So Java runtime is not gonna do time slicing. Java runtime is going to check the currently running thread. It will run even if there are other threads with the same priority. Java runtime is gonna make sure that the first thread is completed before the second thread can run. So Java runtime does not do time slicing. Another one is round robin, okay? So in this one, highest priority thread runs at all times. But if there are multiple highest priority threads, each executes for a short amount of time. Let's say that there are 5 threads and 3 of them have the highest priority, okay? So the first one starts running, only the highest priority threads will run until they are not runnable, and they will do time sharing among each other. Okay. If the currently running thread yields CPU, yielding means it allows another thread to execute by calling the yield method. Thread class has a method called yield, okay? You can call that method. In this time, scheduler will implement a simple non-preemptive round-robin scheduling order in this case. So basically, if you do yield, that thread waits and looks for the threads of high priority, and then they will start executing in a round-robin scheduling order. JVM implementation, Java virtual implementations on different operating systems may choose to have different scheduling mechanisms. Therefore, don't trust too much, okay? Be very careful. And you're gonna see there are a lot of examples that may generate unpredictable way. However, there are certain methods of thread class, and they will execute the same way. And that's what we're gonna focus now. The first method is sleep method. A thread may be executed indefinitely. For example, you may have a for loop, and in that for loop, in the run method, you may have a for loop that may be an infinite for loop. That means then if you make a call to that run method by a thread, that thread will run infinitely and indefinitely. But then you can have a call to sleep method of thread class. That's a static method. Here you go, public static void sleep. There are 2 overloaded sleep methods here. One takes only milliseconds, the other one takes milliseconds and nanoseconds. So sleep method is going to make the currently running thread sleep for defined number of milliseconds right here. Pay attention, it throws interrupted exception. If you go to exception handling video lecture, you will see that interrupted exception is a subclass of exception. That means that's a checked exception. So if you want to call sleep method, you must call it in a try and catch block. Otherwise, Java will not compile. Let's see this example. This is a very interesting example. I want to spend a little bit of time. So stop the video and take a look at it, okay? So I have class run test implements runnable. So since I have runnable interface, I guarantee that I'm going to implement what? Run method. So this is required. What does it do? It has a for loop from 1 to 3. It first print thread colon, and now look at this thread.get current thread.get name. Basically, current thread is a static method of thread class. How do I know that's a static method? Well, I'm calling with the class name, right? Class name dot method name. That means that this one is a static method of thread class. That's clear. And then that is going to return, this is going to return an object. And via that object, I make a call to get name. So basically, to make it short, thread.get current thread.get name is going to return the name of the currently running thread. Okay? You can either give an explicit name to a thread that you create. Otherwise, Java is going to give default names starting from 0, 0, 1, 2, 3, and so on. And first, it will print the name of the thread. Then it will print I. And then it will try to sleep. That means it will try to stop currently running thread for 1 second, 1,000 milliseconds. Again, try and catch, because sleep method throws interrupted exception, and that's a checked exception, and it needs to be in a try and catch block. Then what do I do here? I create F test and S test. Okay, let's go ahead. So f test is an object of what class? Run test. Okay. Similarly, I have s test. That's also what? An object of run test. Then I create T1. When I create T1, I allocate memory space, but what do I send as input to the constructor f test? That means it takes this guy. Okay, then I have another thread T2. I allocate memory space, but I send s test as input to the constructor. That means this guy goes to here. Okay, so then I say T1.start. When I say T1.start, here T1 goes to runnable mode. And here T2 goes to runnable mode. Okay, are they running yet? No, but they are runnable. That means if JVM is available, it will run. But there is, so those two threads are the threads that I created explicitly, T2 and T1. But there is one more thread currently running. That's called main thread. You see this main method? There's also another thread called main thread. That's the currently running thread. So main thread is running, okay? Right there. This is the main thread. And in the main thread, I execute this line, this line, this line, this line, this line, this line. And I will go and execute this line. So it will print main method exit. Once it prints main method exit, then this main thread will be killed. Now, one of those threads, T1 or T2, can go into running stage or running mode. They were in runnable mode, they were not running yet because they were waiting for the main thread to be executed. So main thread is finished. It showed on the screen main method exit. Then it's gonna go and make a call. Either T1 or T2 will start what? Running. That means it's gonna make a call to run method. It's gonna make a call to run method via what? T1. It's going to start running. It will say thread, maybe thread 0, for example, and it will print 1 and it will go to sleep. As soon as it goes to sleep, that means it is not running anymore. Then T2 will start running. That means I'm going to make a call to run method via T2. It will start from again 1, then this time it's going to print the name of the second thread and print I and go to sleep. While this is sleeping, the previous thread, most likely after a second, will come and continue wherever it stopped. Then it will sleep again. This will continue wherever it stopped. I guess you get the picture. So when we run this, in Windows operating system, for example, I did run this. It prints this one. It prints this. It says first main method exit. Why? Because I completed the main method. Main thread is gone. Now the first thread starts, the first thread, which is called -0. You see that? Remember thread, the Java is going to give default name. Thread -0 is going to be the name of the first thread. Thread -1 is going to be the name of the second thread, okay? So it will come, I is 1. It will say thread 0, and I is 1. And it will go to sleeping. The other one will come, thread 1, 1. Then it will go to sleeping. And the previous thread will continue. It will print 0 and I is 2. It will go to sleep and the next one will come. Again, it will go to sleep and so on. This is what from the Java runtime we expect. However, when you run the same thing in Mac, I got something else. You see, it did not, because it was doing time slicing in this case, most likely, and it did not follow proper execution order. So first it went to thread 0, executed this for a while. Before it was able to print this, thread 1 started executing and it print thread 1, and then second thread came, completed printing 1, and then okay, let's start. Let's start again, sorry. Here, main method exit. So the main thread is gone. Then we have T1 and T2, they are all runnable. But in this case, thread 0 starts running. That means it goes here, I is 1, it prints thread 0, boom, at that point, maybe due to time slicing, thread 1 will start running, and it will print thread 1. And at that time, again, due to time slicing, maybe, what's gonna happen, thread 0 will come back and continue and will print 1. At that time, it will stop, and the other one will come and print 1, and so on. So again, for example, here thread 1, 0 comes before thread 1. It all depends on the execution mode of the operating system in this case. Thread slip method throws interrupted exception. It must be handled in your code. Why? Because I checked the exception, as I said. Okay. So here are some important methods of thread class. Public, static, native, boolean is alive. Look here. This has no implementation. It has just semicolon. Remember native? Native methods are defined in a library that is developed in another programming language. So this is alive is not developed in Java programming language. It comes from, maybe it's C, maybe it's C++, okay? It comes from another programming language, and a library from another programming language. And then we have get priority method. This is final. If a method is final, it cannot be what? Overridden. Set priority is also final. So these two are the methods of thread class, and this is also a method of thread class, but it is not defined in Java. Of course, is alive, as you guess, it shows if the thread is dead or not. Thread does not have to be in the running state in this one. I mean, whatever stage or state that the thread is alive is going to return true as long as thread is not dead. Okay. And we have those constants. Okay. I should have put, yeah, public, final, static, final. That means they are constants. We have min priority, norm priority, max priority. Okay. So these are the constants. So another method, join. Join is a method that will make the current thread wait until the thread on which the join method is called terminates. So I'm going to show you with an example. So that means a thread may try to join, okay? And then you stop the currently running thread until the thread that joins executes and completes the execution. Yield is another method. That's a static method. It gives a chance to run other threads in the runnable state, only if they have same priority. Assume that there are multiple threads in the runnable mode or runnable state, and when you do yield, the current running thread will stop and give a chance to the other threads of the same priority in the runnable state. The difference between slip and yield: slip gives a chance to threads to run regardless of their priority. I'm going to slip, okay? You can pick whichever thread that you want, but yield only yields to the threads of the same priority. Okay, here is our first example. Let's see what happens in this one. I have run test, runnable. I did override run method of runnable. Simply from 0 to 4, it will print 5 times the name of the currently executing thread. That's basically what it will do. So here, I create an object of run test, f test. I allocate memory space. Then I have s test. Okay. And again, I create T1. And this is input to that. I create T2. This is input to that. And when I say start, that means, okay, this becomes runnable. And this becomes runnable. Are they running? No. Why? Because I have my main thread running right now. This is the main thread. Okay, so it's going to print what? Main method exit. As soon as it prints main method exit, main thread is gone, right? Now, assume that Java picks the first thread. It goes to running mode. It goes to running mode. Running mode means what? Go to running mode and print thread and the name of the current thread. How many times? 5 times. Okay. And then the second thread, when this is done, the second thread will start and it's going to print what? 5 times. So this is what we expect to have, something like that. The main method exit and 5 times thread 0 and 5 times thread 1. This is with Windows operating system. This is for regular Java runtime environment. Do you remember I said it was deterministic? So it picks the first one, completely runs that. When it is done, runs the second one. But if I run it in Mac, well, maybe this is not the scheduling that Windows, and even in Windows, it depends on, this is older version of Windows operating system. So it depends on the type of operating system that you have. Here, I have the main method exit. This 2 was runnable. As soon as main method exit, now things becomes complicated because T1 and T2 will run in different order. It's not gonna complete the first run method while you are in the middle of run method. Maybe second thread will be given time due to time slicing and so on. Okay, or round robin because they have the same priority in this case. Default is 5, by the way, priority. So what happens here? Okay, this is a little different. I mean, everything is the same until a certain point. I have F test, again S test, and then T1, and then I have T2. Okay, now this is where runnable. Okay, and which thread is currently running? Main thread. So they all have the same priority, main, T1, T2, okay? But here, I say set priority right there, and I say max priority. Remember, the norm was 5. So main has 5, T1 has 5, T2 has 5. Now I say T2 will have what? This will have the topmost priority. So in a typical Java runtime environment, what I expect that main method will allow T2 to run. So therefore, main method will stop. So main thread will stop. T2 will run. So 5 times it's going to show the name of T2. And then it will go back to the execution of main method maybe. And it will say main method exit. And then it's going to run T1. So in a typical Windows or in a typical environment, you may see this. For example, here, first, T2 set priorities max, right? And whenever I start T2, it's going to make a call to what? T2. It's going to stop the main thread T2. T2 is named thread under thread -1. T1 is named thread -0. So it will first execute T2 here. Then it will execute complete execution of main, and then it will execute or run T1 thread. Of course, if it is not Windows, it may be something else. Okay, in Mac, you don't expect to have, but this is in a typical Java runtime environment, regular scheduling. Okay, how about this one? What do we expect to have here? Okay, I guess you can tell me. This is pretty simple. It's going to, first, I have the main thread. Then I have T1 and T1. I have first. So, okay, so main thread runs. It will complete the main thread. It's going to print main thread exit. And then T1 will go to running mode. That means I'm going to make a call to this one. So from 0 to 4, it's going to print the name of the thread. Okay, 5 times. How about now this? Let's see. Okay, stop the video, take a look at this. It is actually pretty simple. So I'm gonna go and create first. First is an object of what? Run test class. That means it's runnable, okay? First test is a runnable object. Then I create T1 which is the thread, and I use first as input to the constructor. That's how I show it, okay, for you. Then, which thread is running right now? Main thread, right? Main thread is running. So it will do this, and it says T1.start. That means T1 goes to where? T1 goes to runnable mode. Runnable mode or state. That means if JVM gives time, T1 is ready to run. Then I say try T1.join. Join is a method of thread class. Again, join throws an interrupted exception. Therefore, I have to call it try and catch. What join does, it says, currently running thread, can you give me time? Can I join? So maybe right here, main thread will stop. Okay, main thread will stop. It will go to runnable mode. Main thread will go to runnable state. Okay, goes to runnable state. But it will give time. It will go to runnable state until it is not going to be runnable in the runnable state until T1 is finished. So T1 joins. That means T1 is going to make a call to run method. And 5 times we will see the name of the thread. Once T1 is done, then main thread will continue wherever it stopped. So in this case, we are going to see 5 times the name of thread and then main method exit. So join is going to stop the currently running thread, which was the main thread, and get into and execute itself, and then let the program continue wherever it was before. So this was the first way to create threads. What was the first way? Just let's remind ourselves. First way is, first you create a class, First you create a class that implements runnable interface and implement run method. Second, create an object of that class. Third, create an object of thread class using the constructor that takes a runnable object, and then make a call to what? Start method. This was the first way. So it's a good way. I mean, it's a very good way. Second way, this time we will have thread class. So our thread class implements runnable interface. Remember, we had class thread, extends object, implements runnable. That means a thread object is a runnable anyway. So if I can extend, instead of implement runnable, I can say extend threads, because threads implements runnable. But this is not a good object-oriented programming approach. I will explain why. Let's see this. So here I have my class. I say extends thread. A subclass object is a superclass object. A test object is a thread. Okay? Since thread implements runnable, I'm overriding the default run method implementation in the thread class. Remember, thread class had an implementation of run method. It was a very simple implementation. Now when I say extends thread, I'm overriding that run method this way here. Okay? Then I create an object of thread class. But pay attention, I don't say thread T1 is equal to new thread. I say thread T1 is equal to new test. Can I say that? Yes, because a grad student is a student. A test is a thread. I can assign a grad student to student. I can assign a test object to thread. A Honda is a car. I can assign a Honda to a car. I can assign a test to thread. So I create a test object and assign it to thread. And then I make a call to start method. Then it will create a thread called T1. It will take it to runnable mode. That means whenever JVM is available, go and make a call to the run method right there. Is this a good approach? No, because when I say public class that extends thread, I lose all of my other options to extend. For example, a class can extend from only one other class. When I say test extends thread, that means test will not be able to extend from another class that I may need. But in the previous example, when I say run test implements runnable, A class can implement multiple interfaces, no problem. But a class can extend only one interface, one class. Therefore, this is not a good object-oriented programming approach. Okay. So when I run this program, as you see here, I created a thread. It's in a start mode. It's in a runnable mode. And it's going to make a call to run method. And 5 times it prints thread 0. Okay, you can have multiple overloaded run methods. However, the run method that is defined as public void run will run automatically, because that's the method that's defined in the interface runnable. Okay, so if it is public int run, yeah, you may have it, but it's not going to run automatically. Okay, if an object is reachable from a thread, that object cannot be garbage collected. Just as side information. Okay, let's see how well you understood, and let's see what we expect that this program is gonna print. Okay, this is pretty straightforward actually. Let's look at this. I have class test extends thread. That means test is a thread, and then I have x static and it's initialized to 0. Everybody agrees on that. Then I have a run method here, and I have another run method here. This is public void run. That means this is overridden method of thread class. This is just an overloaded method. This is another run method. Then what do? I create obj. Obj is an object. Object of test class. A test is a thread, right? So obj is a thread. So when I can say obj.start, because it's gonna go and make a call to start method of test class. Test class doesn't have a start method, but thread class has a start method. So it's going to make a call to start method of this class. So it's going to take this guy to runnable mode. Okay. But is it running yet? No. Why? Because I have the main thread right here. I did have that. I have this. Right now, I'm going to go and print X. Then obj is going to go to running state, but obj is not in the running state yet. First, I'm going to go and print 0. Okay, then it will go to running state, and it's going to make a call to what method? This guy, and it's going to change x to 30. But it's too late because I already printed 0. Okay, so how do we fix this one? How do we make sure that, how can I change this one so that on the screen I will not see 0 like here, but I'm going to see what? I'm going to see 30. You can stop the video and think a little bit. Actually, it's pretty easy. This is how I can do it. Now let's take a look. First, here I have the main thread. This is the main thread. Okay, and I do this. That means I create obj. Obj is an object of test class which extends thread. That means obj is a thread. Okay, this is a thread. Okay, then I can say obj.start. That means this will go to what? Runnable state. Is it running yet? No. Which thread is running? Main thread. Then I say try obj.join. Now obj will tell the main thread, can you stop for a second so that I can run? So main thread will stop at this point. Obj will run. Obj will run means what? It's going to make a call to what method? Run method. Which one? This one? Oops. Is it this one or this one? Obviously this one, because this takes an integer. And it's going to change x. X was initially 0, but x will be changed to what? 30. Now, am I done? This will go. This is not in the runnable state anymore. And that means main method will continue. And main method will print 30. Okay? So I hope you understand join method, how important it is right there. Okay, now we are going to talk about some important concepts, because doing multi-threaded programming is not that straightforward. You have to be really careful. Threads share data from shared memory. So in a process, There's a memory, and threads will share data from this memory. Okay. In fact, a thread interacts with another thread via that shared memory. What happens is they copy the original data into their working memory, their local memory. A thread will get a copy of data and put in their local memory. And that means every thread will have some kind of local memory, and they will work on the copies of the original data. When they are done, they will place the copy back to the original space. But this may cause a problem, because I have a local copy, another thread is a local copy, and both of us are working in a local copy, right? But what about one make a change, and that change, and I make a change too, both of us, and then we go and change the original data memory? That's gonna cause a problem unless we have some kind of order there, right? So that's what we are going to talk about. Shared memory has locks. What does that mean? Hey, if I get a local copy, I tell Java that I am locking this part of the memory. Why? Because I have the local copy myself. Until I am done, I don't want anybody to mess up with that space. Okay? So that's why we have locks. Every object has a lock associated with it. And threads will ask for locks. Say, I'm gonna get and have a lock there so that no one else messes up while I'm working on it. So here is an obvious problem I'm gonna tell you. Multiple threads can operate on the same object at the same time. I mean, there's an object, one thread is working on it, another one is working on it. That's dangerous. So what happens is, first one thread can get a lock of this object and modify it. In that time, the other thread cannot access to the same object. Okay? Unless we have such a locking mechanism, we are going to be in trouble. And I will show you with an example. Let's look at this one. What do I have? I have a class called data that is an index, and it has an array of size 10. Data has two data members. One is an int index. The other one is a double array of size 10. It has two methods. One is add, the other one is remove. What does add method do? It goes to the current index, the location of the array or the component of the array with the current index, and assign whatever the input argument is. D is assigned to that array location. And then index is increased by 1. When I remove first, I decrease index by 1 and get that component and return it. Okay? For example, if this is the array, okay, assume this is 3.5, 5.6, and so on. Assume that index is 6. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, sorry. So this is the index. Assume that index is 6 right now. And when I make a call to add method, somehow if I say add 200, it's going to go to here and put 200. And index will become 7, okay? It will take 200 and index will be 7. If I want to do remove, index was 7, first index will be 6, and then it's going to return this 200. Okay. Then I have a class, as you see, data test implements runnable. So that means data test is a runnable object. What does it have? It has a data member called data whose type is this data. Okay. So this is my class, and data test has a data member called data with lowercase d whose type is data. And I have Boolean adding, that's a just Boolean variable, I call it true. And then the constructor of data test takes a data object D and assigns that to this data member data right there. So let's see what's happening with this example. Let's take a look. I have first, I go and create an instance of this class. Here, D points somewhere in the memory in which I have index, which is 0, and then I have an array. It points somewhere else in the memory, in which I have an array of what? Size 10, 0 to 9, okay? So with this one, I created an object of this. It has index 0, and then it has an array, points somewhere else in the memory in which I have an array. So what do I do here? I create an object of this class, okay? I create an object of that class. Let's call it first. I create an object of this class. And as you see, which constructor do I use? This one, D. D was this one, right? I send it as an input argument. So the data of data test, this one has something called data. It will point this memory space. Why? Because of this D. Then I create another one called second. Okay. I create second, again, the same D. That means data here will also point this guy. You see? And then I create thread 1. I have thread 1, and I have thread 2. For thread 1, I have this guy. For thread 2, I have this guy. And then I make them run. Okay, so what's happening? As you see, both thread 1 and thread 2 are created using the same data. They point the same data. They work on the same data. So what if thread 1 makes a call to add method, while thread 2 makes a call to remove method? Well, due to time slicing, maybe thread 1 will not be able to finish this 2. Maybe it only does the first one, and while before it is able to increase index, the other thread comes and decreases index right there. So this messes up everything. Okay? So unless thread 1 completely finish adding operation, we should not call the remove method from the other thread. Otherwise, it's going to mess up indexing, and it's going to mess up your add and remove operations. Okay, I hope this is clear, because both of them operates on the same data. So they're gonna mess up. So how can I solve this issue? How can I solve this issue? Well, it is easy. I'm going to use something called synchronized, and then this. I'll explain that, but you put a synchronized block. You see that either this 2 becomes a block. That means I am putting a lock, and that lock, whoever has that lock, whichever thread has that lock, will be able to execute those 2 lines. Until those 2 are executed, I will not release that lock. Similarly, I have another lock here. That means whoever has access, whoever has this lock, whichever thread has access to, whichever thread has this lock, will be able to execute this and this. Then the lock will be released, and the other thread can go and execute that one. Okay? So now we saw that issue with putting synchronized. So what synchronized means? We need to make sure that the shared data is in a consistent state before used by any thread. Each object has a lock. Synchronized keyword gives exclusive access to the shared data. Okay? Synchronized block. We have synchronized block. Synchronized blocks takes an object as input. They wait to lock on an object before they can execute. So this block is going to get a lock on this object, first of all. Okay? Then once I have that lock, the body of the block will be executed. And once this body of block is executed, the release on the object is going to be, the lock on the object will be released. This is what I try to explain. When reach synchronized Java, synchronized block, Java checks object. passed as input argument, which is this in this case. This refers to the caller of the add method. This refers to the object that called add method, okay? Java checks object passed as an argument and tries to obtain the lock of the object. So whoever is the caller of this add method is this, okay? So then the lock of that object will be obtained. That means until this block is executed, that object cannot be accessed by anybody else. Okay? All right, so let's go to this one. These two are equivalent. If the whole body of the method is synchronized with this, you can move synchronized keyword in front of after public. You can say public synchronized void add. These two are equivalent, okay? That means the whole body here is synchronized, parentheses this. They two are equivalent. And this is good. This one is better in the sense that there is something we never discussed, but there is something called Java docs. So Java documentation, for each method, you can create some kind of HTML or some kind of documentation. I'm not going to get into detail it, but when you have synchronized keyword here, that documentation can tell that add is a synchronized method. In other words, everything in the add is synchronized like that. Okay, so now we have seen synchronized. We have seen public, final, abstract, static, and so on. But now we have seen what? Synchronized. A method is synchronized. Okay. Only one synchronized method can run at a time. For example, now I have a class test. There's a deposit and balance, two methods. Both of them are synchronized. What does that mean? That means one of them can run at a time. One thread, if one thread is running deposit, another thread cannot go and run balance. In fact, that's the whole purpose. Because if I'm depositing money on an ATM machine, unless I complete depositing my money into that ATM machine, I should not be able to check my balance, right? Because I'm in the process of adding money. So the balance will not be true balance that I have. So if you put synchronized keyword, that method can be called only by a single thread. Another thread, if deposit is called, another thread cannot call balance, for example. Synchronized keyword cannot be used as modifier for instance variables. For example, you cannot have a synchronized data member. It makes no sense. You can only have what? Synchronized methods. You can have synchronized methods or synchronized. Also, you cannot have synchronized like this. So data members cannot be. But here you can get, for example, here synchronize this is within the class. It makes no sense. Synchronize object should be in a local scope, just like this. Okay, now let's see. What is deadlock? Deadlock is something you need to try to avoid. Assume thread 1 might be waiting for a lock that is held by thread 2. Assume thread 2 has a lock of an object, and thread 1 is waiting for that lock. But at the same time, thread 2 is waiting a lock that's held by thread 1. So that's a deadlock, because thread 1 is waiting for thread 2 to release something, but before thread 2 can release it, it's also waiting for thread 1 to release something else. So that's called deadlock. And we have wait, notify all methods that will be helpful to get out of deadlock. These are methods of object class, and threads may need to interact, and those methods are used for thread communication. Okay, so wait, notify what? A thread may notify another thread, or a thread may notify all other threads. Okay. Let's assume thread 1 issues wait on an object. Then thread 1 waits until another thread issues notify on the same object. So I said, I am thread 1, I'm going to wait on an object. I'm waiting until what? Another thread notifies me that that object is available. Okay. Okay, you must have the lock of the object. You can call them from a synchronized block. Okay, let's see. This is from Java API, Application Program Interface. Wait method throws what? Interrupted exception. You see here. Wait method in the object class is public final void wait. That's final. That means it cannot be what? Overwritten. And it throws interrupted exception. Interrupted exception is a checked exception. So if you want to call wait, you have to call it in a try and catch block. But notify and notifyAll, they don't throw any exceptions, right? Okay. In order to call wait, thread must own the lock of this object. Okay, let's see what it means. By the way, wait, notify can only be called from synchronized blocks or methods. Okay, now stop the video and take a look at this because this is important. So I have a class called common, which has two data members, x and done, and two synchronized methods, read value and set value. Synchronized means what? They cannot be run at the same time by two threads. Okay, if one thread is running read value, the other thread cannot run set value. So this is synchronized read value int. Basically, read value will return x ultimately. Okay, it will return x. Okay, set value is going to set x basically, but there are other stuff that we do for some reason. But ultimately, it's very simple. It's going to return x, and this is going to set whatever input as x. It will assign value to x. Okay, so that's what I'm trying to do. But I have something else here. What do I say? Initially, okay, if done is false, then I'm going to wait. Okay, okay. Let's keep this one there. Okay, now let's go to the next slide. What's happening here? I have class test1 extends test. Sorry, test1 extends thread. That means a test1 object is what? A thread. And obj common. That means I'm creating an instance of common class, right? I'm creating a reference to common class. I didn't use new keyword. I did not allocate any memory space, okay? And test1 takes a common object as input and assign it to obj. And then I have the run method. Run method goes from 0 to 3 and makes a call to set value. How many times? 3 times, okay? That's test1. Then I have test2 that also extends thread. It also has a constructor, but test2 run method makes a call to what? Read value. So I will have two threads. One is going to make a call to set value. The other thread is going to make a call to read value. Okay? So that's what I'm going to do. So now here what I do. I create an object of common class. Let me go and do it. This is the common class, right? It has only x and what? Done. Default value for x is 0. Default value for done is what? False. So that's what I'm going to do here. So I have A has x, which is 0. And the other one was what? Let's see. Done is false. Okay. Then what do? I create an object of test class, test1 class. I create an object of test1 class. Which constructor do I use? The constructor that takes a common object as input. Whichever it is assigned to this one. So here I create test1, and test1 has, as you see here, test1 has only one data member called obj. It has obj, and obj is A. That means this points right there, this memory space. Similarly, I have test2. It also has obj. Let's go back. As you see here, test2 is also obj. And it also points where? Oh, sorry. It also points to this memory space. So now we are sharing data. Both test1 and test2 have access to what? This memory space right there. And both of them are in runnable mode, so they're gonna go to running. Now, this guy is gonna try to what? Let's look. Set value. The other one's gonna try to what? Read value. We are lucky. Why? Because we synchronize them. That means if one is reading, the other one cannot set. If we didn't have those synchronized blocks, we would be in trouble, because while one is reading, maybe at the same time the other one is changing the value. But now we solve that problem. Okay, so what happens? T1, test 1 goes to runnable state. This goes to runnable state. And assume that this goes to running state. Going to running state for test 1 will be what? Going to make a call to what? Run method. And 3 times it's going to set the value. A0, it will set A0, test 1, 0. It's going to sleep. While it is sleeping, the other one may read it. So this will set 0, the other one will read as what? 0. Then A will become 1. This will set it to 1. It will show 1. It will go to sleep. The other one will come and read it as 1. So everything is fine in this case. So this is what in a regular Java runtime you should see this. Okay. So that synchronization helped us. Okay, let's go to, I also suggest that you spend a little bit of time on this, okay? And then I remove synchronize block here, what happens? Just to spend a little bit of time on that example. All right, let's see some fun examples. I have this. What do you need to do in order to see a 1,000 on the screen? First of all, what happens when I run this program? Let's see what we are gonna see. Okay, I have the main thread right there. This is the main thread. Okay, and then I do test, extends thread. I did override thread method run right there, and I create an object of thread class using new test. This is the second way of creating a thread, right? So now I have this T1 is created, and this goes to runnable state. However, since the main method is running, it's going to print total, and it's going to print what? Basically, it's going to print a big 0. Once it is done, then this will go, and it's going to go and make total 1,000, but it's too late because on the screen we are going to see what? 0. So what I need to do, what do I need to do so that I will see 1,000? What if I go here and I say right there, right here, try t1.join and then catch? This will solve the problem, right? Because the main thread runs, it will run that, and then join. Before it prints total, it will stop and allow what? J1, T1 to run. And T1 is gonna make a call to run. Total will change from 0 to what? 1,000. Then once I'm done with this, main method will continue and it's going to print 1,000. So join T1 to main. That's what we need to do. Okay. All right. What happens when I run this? Is there any problem here? I don't see any problem. First run implements runnable. It implements run method this way. And I created an object of first run. And I created an object of thread class, sending this as an input and start. I don't see any issues. It will run and it will print start and end. What method starts thread of execution? Start method. Okay. Which method is in the body of the thread class. Of course, run method, right? When we extend from thread class, we just simply override the run method. Okay, here I have class test implements runnable. So how can I create a thread here? Let's see, is the first one okay? Well, it makes no sense because this is the class name. The class name makes no sense here. But here, what do? First, I create, this makes no sense either, right? They have the class name, it makes no sense. How about here? First, I create an object of test class. So obj is runnable object. Why? Because test is a subclass of runnable, a subclass object is a superclass object, and a test object obj is a runnable object. Then I can go and create a thread using runnable object as input. So the answer is 3. Okay, this will be a little tricky. So take a look, stop and take a look. We are going to use anonymous interface in this case, anonymous interface. What does that mean? See, I have thread example here, this line. This is really nice. I hope you will fully understand this. If you fully understand, that means you can bring inner classes concept together with this one. So thread class constructor takes a runnable object as input. Thread class constructor takes a runnable object as input. Well, for a constructor, for an interface, can I create an object of an interface? Can I do this, for example, new runnable, like this, maybe runnable X. Can I do that? Can I create an object of an interface? No, I cannot do that. But then, what am I doing here? Am I doing here? But look here, look right here. Oh. I am creating an object of an anonymous class that doesn't have a name, that implements runnable interface and overrides run method of runnable interface this way. So basically this, everything that you see in green is an object. Does that object have a name? No. Whose object is it? What class? It is an object of an anonymous class. That means the class doesn't have a name. But what all I know is that that anonymous class that doesn't have a name implements runnable interface, and that means it overrides the run method of runnable interface this way. Then when I say t.start, first I will see main method exit because main thread will be completed. Then this t will go to running mode or running state. When it goes to running state, it's going to make a call to the run method of the runnable object that I fed into the constructor. And the run method of the runnable object that I fed into the constructor is simply this run method, and it's going to print here. Okay, here's one more example. Well, in the previous one, I named the thread. Did I have to? I mean, I don't. What I do here, this is beautiful. Look here. Okay, this is a, okay, 1 second. This is a thread object. You see, I create a new thread. I use the constructor here, right there. Please pay attention to this and that. That's the constructor, the input to the constructor. What is the input to the constructor? That's an object that doesn't have a name. That's an object of a class. That's an object. That's an anonymous object of an anonymous class that implements runnable interface this way. So I create a thread using the constructor that takes a runnable object, and I start that thread right there. Okay? So that means as soon as I'm done with main method exit, this thread, which is in the runnable mode, will run. In other words, it's going to go to the input object and make a call to the run method via that input object, and it's going to print here. Okay, how about this one? This looks also very weird to me, but let's see if you will fully understand this. This is tricky. Look here. I am creating an object of a class that doesn't have a name, that extends thread class and overrides run method of thread class this way. Okay, when I say thread T is equal to new thread, look, these two are totally different. Thread T new thread. If it was like this is totally different than this. This is clearly a new thread class object. Okay, but my case is different here. With this one, I don't have semicolon there, right? With this one, I'm looking for the whole thing. I create an object of a class that extends thread class and that overrides run method this way. And then I start that thread. So first main method exit, and as soon as this is in running mode, it's gonna go to that object and make a call to what? Run method of the object is going to print here. Let's make it a little bit more. I mean, this is also the same. Just I am creating an object of a class. I'm creating an unnamed object of an unnamed class. All I know is that class extends thread class and overrides run method this way. So this is an unnamed object of an unnamed class, and I make a call to start method of that unnamed object here, because I know that that unnamed object is a thread, because it's a superclass is the thread class. So the same thing will happen right there. I hope this is not too much. Okay. So this is another way of looking at it. Public class thread example implements runnable. That means an object of thread class thread example is a runnable. Okay. So that means when I create this guy here, I'm creating an instance of thread example. That means I'm creating a runnable object. Therefore, I can send it to the constructor of the thread class. You get it? I can send it to the constructor of the thread class. I started main method exit. This is running. That means go to the input argument that I fed into the thread constructor. That's thread example, right? Go to the run method of that class and run it. So it's going to print here. Okay, so, well, I can directly call run method. It has nothing to do with thread, okay? When I say t.run, okay, so this is the main method, so main thread. I do this, then I will do this. It's gonna go to run method, just like a regular method. It's going to print what? Here. It's gonna print here. Then I'll go to start. Start is gonna take the thread into what? Runnable mode. Is it running? No. And then main method exit. So it's going to print main method exit. Then this guy will go to running mode. When it goes to running mode, this time it's gonna make a call to run method. Okay? And then it's gonna print here again. This is explicit call just like a regular run method. But this one comes from whenever the thread starts running, it's gonna make a call to run method there. Okay. How about this one? This is interesting. We have a method. Inside the method, look, again, anonymous interface here. Anonymous inner interface here. I create an object of an unnamed class that implements runnable interface this way. OBJ is an object, okay? So I create an object of an unnamed, I create an object of an unnamed class that implements runnable interface this way. Then thread class constructor takes a runnable object as input, so I send OBJ as input, okay? This is perfectly okay. Then I say start. That means when I say start, oh, we are in the main method. Sorry, we are in this method. Okay, so now this is the main thread. I'll do this. I create, and I make a call to method, because method is non-static, and this is static. That's going to go inside the method. It will create obj, and it's going to create a thread, and it's going to take that thread to what? Runnable mode. And as soon as I'm done with the main method, that thread will go to running mode. Going to running mode means what? Go to the input argument that you had here and call the run method via this object. That means go and call the run method right there. It's going to print here. I know this is kind of over and over, but I want you to fully understand object-oriented programming concepts here. Not memorize, just understand. So here, thread example implements runnable. Since implements runnable, I'm implementing the run method. Then, this is perfectly okay, right? Why? When I say new thread example, it is new thread example is runnable. And thread constructor takes a runnable object as input. Then I make a call to start. Main method exit first. Start means go to this object and make a call to run method via this object. That means go to the run method of thread example class and run that. Well, you cannot call start method twice. If you start it, you cannot start again. That's a compile error. Okay, this is interesting. Public class thread example implements runnable, right? And since I said implements runnable, I have what? Overridden the run method right there. Then I have the main method. Well, when I create the thread, okay, when I create the thread, what am I doing right here? I am creating an object of an unnamed class that extends thread example and overrides the run method of runnable interface this way. Look, thread example is runnable. Now I am creating an object of a class that extends thread example. That means that object is also runnable because it is like subclass of subclass. Okay, so I'm creating an object of a class that doesn't have a name, that extends thread example, and it overrides the runnable. It overrides the it overrides this run method this way. Okay, I repeat. I'm creating an object of a class that extends thread example, and thread example has a method run, and I'm overriding it this way. Okay, so I'm overriding this method right there. And when I say start, when it is running, it's going to make a call to which run method? This run method or this run method? It's going to go and get the object it created here. Okay, well, it created this object, right? So, oh, wait a second. I think I made a mistake. Hold on. Okay, new thread. Yes, I made a mistake here. Yeah. Sorry. Let's take it over. Because I didn't pay attention to this parenthesis and this parenthesis here. Okay. So look here. My apologies for that. So here I am creating an object of a class that doesn't have a name, that extends thread class. And it takes this one as an input argument. When it extends thread class, it overrides the run method implementation of thread class this way. Okay, so that's what happens. So now when I say start, if it is in the running after main method exit, when it goes to running mode, it's gonna go and make a call to the run method via this object that I created right here. Therefore, it's going to make a call to this run method. Okay, here. Okay. Well, let's see. I have thread example. Extends thread. I have constructor here. I have a run. I have a method. And let's see what's happening here. I create an instance of thread example and I make a call to method. This method is non-static, this is static, that's why I did that, right? So I make a call to method. First, the constructor. The constructor will take me right here, okay? So what am I gonna see? Here, 1. Then it will go start. Start what? I'm making a call to this constructor via what? T, right? That means I'm gonna start. That means T will go to runnable mode. Runnable mode. Is it running yet? No, it is in the runnable mode because right now main thread is running. Main thread is running. This is there. Now that means this T is in runnable mode. Why? Because of this start. But is it running? No. Then I will go to second one. Second line. That means I'm going to go and make a call to this method. Therefore, I will see here 3. Here 3. Then it will say join. Well, what is joining? Who is calling this method? T is calling, right? So T says, may I join? That means can main method stop and can I join? If I join, that means I'm going to make a call to run method via T. Okay, that means I'm going to make a call to run method right there. So I will see here 2. Once I am done, I will see here 4. Here 4. And that means I'm done, join is done, and then main method exit. I guess I'm going to see something like that. Okay. Okay, if you recall from exception handling conversation, if I want to get rid of this try catch, what can I do? I can get rid of that and I put throws statement here, throws exception, okay? So this also works here, throws exception. And in that case, I can do this. I can say throws exception. Then I can get rid of this. However, whoever is calling this method must have try catch. Try catch. Otherwise, still compile error. Okay. However, if I also go and put here throws exception, then I can get rid of those as well. That's exactly what I do here. I put throws exception here, throws exception here, so that I don't have to use try catch blocks at all. All right, so why is there a compile error here? Okay, can you guys tell me immediately? Join, it throws an exception, it must be in a try and catch block, right? That's obvious. Okay, so let's see. We have 2 issues here. Look at the run method. Run method throw new exception. Exception is a checked exception. So that means you should have try and catch blocks. Whoever called the run method, that means you should have try and catch here. But second, also when there's throw new exception, this is unreachable, this statement. There are 2 errors here. However, instead of exception, if it was runtime exception, null pointer exception and null is a runtime exception, and runtime exception and subclass are unchecked exceptions. That means I don't have to have try catch when I call run. Okay, that's perfectly okay. In the previous one I had to, but in this one I don't. However, when I run this, it will, okay, let's see what happens. When I run, I have the main thread. It's going to do that. It's going to do that. It's going to print main method exit. Okay. And it's going to go to the run. It's going to print here 1. Then it will throw an exception. Since I don't have anything to handle it, it's going to crash. Your program will crash. What does this print? First of all, this is compile error. Why? Because slip throws interrupted exception as a checked exception. You must handle it. Just like this, for example. And this will print main method exit. Okay. In the previous one, try catch, I can move interrupted exception all the way here, and I can say throws interrupted exception, then I can get rid of those try and catch right there. This is what it is. It's going to sleep 4 seconds before it prints main method exit. Okay. What is this? Again, I move this throws interrupted exception here so that I can have, why did I move it there? Okay, let's see, did I have to have it? Actually, no, but anyway. So here, it is going to first print here too. It's going to make this one start. That means this will go to runnable mode. Is it running? No. It's going to go and print here 3. It's going to print main method exit. That means I'm done with the main thread. Now I can go and run this, and that means I can print here 1. Okay. Now this is a little different, but actually I'm sure you are very comfortable by now. This is the main thread. Okay. It's going to go and print here 2. Here 2. Then start. That means this will go to what? Runnable mode. Is it running yet? No. It's going to go and print here 3. Then it will say t.join. Hey, I know I'm not running yet. I know main thread is running, but may I join? Yes. That means it's going to go and make a call to run method and print here 1. And it's done. And then I will continue wherever I stop, main method exit. Okay, so I think this is all I just wanted to share with you. It's tricky, but it's not that difficult. So this requires kind of experience for you, but there are 2 different ways to create a thread. First, you create a class that implements Runnable Interface. Then you create an object of that class. Then you create an object of thread class using the constructor that takes a runnable object, and then make a call to start method. This is the first way. Second way, you create a class that extends thread class. And then you overwrite the run method of thread class. And then you create an object of the class. You do thread obj equal to new, whatever the name that class that you named. And then you make call to start method. So, and we have join method, slip method, yield, and all the other methods that you should feel comfortable as well. I hope you enjoyed this video, and I'll see you in the next one.